Hi guys, today we're going to talk about similar triangles. In our previous lesson, we talked about similar polygons. And in that lesson, we discussed how to be similar polygons, you must have all angles are congruent and all sides are proportional. Well, today we're going to look at how can I show triangles are similar without showing all the angles are congruent and all the sides are proportional. And we can do that by one of the three ways that we have to show triangles are similar. And the three ways are angle-angle similarity. It's got the little squiggle mark for similarity. The second way is side angle side similarity. And the third is side 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 similarity. So where there are 5 ways to show triangles are congruent, there's only 3 ways to show that we have similar triangles. So to be angle angle similarity, that means your two triangles. So if I have triangle cat and I have triangle dog, and I know that angle C is congruent to angle D and T is congruent to G, I've got two angles marked congruent. So I can say that my two triangles are similar because of angle-angle similarity. So now I can say triangle cat is similar to triangle dog. And just like before with our congruent statements, we had to make sure that they were written in order, like angle C is congruent to angle D, O is congruent to A, T is congruent to G. Same thing with our similarity statement. So this is called a similarity statement, and again, we talked about that in that previous lesson. To have side angle side, if I've got two triangles, we'll do triangle, we'll just keep this simple, ABC. Oops, almost too simple. I didn't even write it in the right place. And angle XYZ. And this time, I have one angle that's marked congruent. We'll just say A is congruent to X. And then I've got sides are proportional, because remember, when you're dealing with similarity, your sides are not congruent to each other. They're just proportional. And those sides have to surround that angle, just like they did when we talked about side angle side congruence. Again, your sides have to be next to that angle. That angle has to be included. And so what you have here is AB, side AB corresponds with XY, because they're in the same place on the two different triangles. And side AC corresponds with XZ. So as long as you have a congruent angle and two sides that are proportional, then we can say that the triangles are similar. So triangle ABC would be similar to triangle XYZ. The last one is side, side, side. So what do you think you have to have here? That's right, you just have to have 3 sides that are proportional to each other. So we can say triangle LOT and triangle SAW. Who knows, just making up some words here. And so here, I don't know anything about my angles, but I know that my corresponding sides are proportional to each other. So all I'm doing is highlighting the sides that line up with each other. They're called corresponding. They're in the same position. And so what we would have is LO corresponds to SA, and that would need to equal OT over AW, and that would have to equal LT over SW. And if you got a true statement where all the sides were proportional, then you could say that your triangles are similar. So triangle lot would be similar to triangle SAW. All right, so the next thing we're going to look at are some examples where I give you two triangles and we have to determine if those triangles are similar, and if they are, is it because of angle, angle, side, or side, side, side. And then we'd write a similarity statement based on the fact that they are similar. All right, so number 1, if you notice, all they have given me are angles. So I'm not going to use side, side, side similarity or side angle side similarity because I don't have any sides. So the question is, are they similar because of angle, angle? Well, I've got 2 angles right now and they're both different, but maybe A is 47 degrees, so it would match angle F. Let's find out. The sum of a triangle is 180, so we can use that information to subtract 90 and 44 to get measure of angle A. And when you do that, you get 46 degrees. So 46 does not equal 47. So there are no 2 angles that are congruent, so it's not similar. And because they're not similar, I'm not going to have to write a similarity statement. So were they similar because of angle, angle? No, I don't have two angles that are congruent. All I have is the one, which is that 90 degrees. All right, number 2. Ooh, we have parallel lines. I've got parallel line PQ, JK. So in here, remember, if you have parallel, same thing as before, you're looking for those F's or those Z's. And I see an F using transversal LJ. So if you take a look, you have angle J is congruent to angle LPQ because of that letter F. Pretty cool. And some folks say, well, what about angle K and Q? You have an F going the other way, and you're absolutely correct. So if you take a look, I have another F using transversal LK, and that gives me, I'm going to use black because I can't see my little yellow tick marks here. K is congruent to Q, and of course I can't call that angle Q because there's more than one angle there, but for right now it's easy enough as I'm just talking about it and I'm not actually writing it. So again, I didn't have any sides, so I wouldn't even ask myself if it was side, 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 or side, angle, side, because they didn't give me side lengths. So we just wanted to know, could we show two angles of the triangle are congruent? And the answer is yes, because of corresponding angles. I have 2 pairs of corresponding angles, so yes, my triangles are similar. And so now I'm ready to write my triangle similarity statement. So I can say triangle PQL is similar to triangle, what is congruent to angle P? That's right, J. What was congruent to Q? K. And then L and L line up. So remember, order matters when you're writing your similarity statement. So on this one, I didn't have any sides. That's why we weren't even looking at side, 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 or side, angle, side. So I wanted to know maybe it's angle, angle. And it was. We had 2 pairs of corresponding angles. You could have also said angle L was congruent to itself because of reflexive. Okay, number 3. Okay, this time they've given me sides and no angles. So obviously, we're not going to be using side, angle, side, or angle, angle, because I don't have any angles. So the question is, are my sides proportional so I can show the triangles are similar because of side, side, side similarity? Well, let's set up a proportion and find out. Easiest way to do this is to look at one triangle, find the shortest leg, and then the other triangle and find its shortest leg, and then set up a ratio. So you have 8/6, and then find the next shortest leg, or the middle-sized leg, which is 12 and 9. So now I'm going to say 12/9. I'm just doing my first triangle to my second triangle, and that would leave 16/12. And you can use a calculator to see what these are as decimals. You can use a calculator to reduce the fraction, or you can just use mental math, which I'm going to do real quick. 8/6 reduces to 4/3. 12/9 reduces to 4/3. 16/12 reduces to 4/3. And because those are all the same, we have similar triangles because of side, side, side. So yes, they are similar. I can now state my triangle similarity statement. I can say JKL. I don't care how you start off that first triangle, but make sure your second one lines up. So J corresponds with Q, and then P, and then M. Sometimes when they don't give you angles, it's kind of difficult to find. Just look at your side lengths and line up your sides. All right, number 4. Just like before, you can add shared sides and vertical angles. So in here, you notice they have vertical angles. You really don't want to use shared sides, I guess, because that would mean they're congruent. And when they're similar, you don't have congruent sides. So really, you're only going to be looking at vertical angles with triangles that are similar. All right, so this looks like it might be side, angle, side, similarity. So we're going to ask ourselves, are the sides proportional? Can't do side, side, side because I don't know anything about my third side. Can't use angle, angle because I only have 1 pair of angles. All right, so my shortest side on the first triangle is 10, and that corresponds with the shortest side of the other triangle at 20. And that would mean 11 goes over 22, and that is 1/2 and 1/2, so they are equal to each other. So yes, my triangles are similar because of side, angle, side. So now I would say that triangle TWZ is similar to triangle, what do you think? Did you say YWX? You are correct if you did. All right. So now we're going to look at some problems that involve similar triangles. So I am going to now flip my page over. And it says problems involving similar triangles. So in the figure, we know that angle ABD is ADB is a right angle. And so we were given BDC was also a right angle. So we know all right angles are congruent. So those angles are congruent to each other. Which of the following is not going to be sufficient information to prove the two triangles are similar to each other? Which one is not? All right, so let's take a look at the first one. It's given me AD, this side here, and it's corresponding to this side here. And I'm just going to dot these because I can't tick them. They're not congruent to each other. And then BD corresponds with CD. So that would be side angle side. So that would be sufficient information to show the triangles are similar. I want not. So let's check B. Let me get rid of my dots here. So B says AB corresponds to BC and BD corresponds to CD. Well, if I look at my triangle, this one on the left-hand side might be easier to use because it doesn't have all these extra dots. You've got a side, side, and an angle. Is that one of the three ways we use to show triangles are similar? Side, side, angle? So this one is probably going to be my answer because it looks like we're trying to use side, side, angle similarity, and that's not one of the three ways. So just to double check, I'm going to look at C and D just to make sure that I haven't made any mistakes in my thinking. All right, C says we are going to have angle ABD is congruent to angle C. Well, that would give me angle-angle similarity. So that's a sufficient way to show triangles are similar. And angle D is telling me I've got three sides that are proportional. So that would be side, side, side. That's a sufficient way to show triangles are similar. So yes, the correct answer there would be B because we're looking for not. All right, number 2, if triangle JKL and FGH are two triangles such that J and F are similar, which of the following would be sufficient to prove the triangles are similar? All right, so obviously we have one angle, so they're probably going to look for side, angle, side, similarity, because they've given us an angle. So I'm going to draw my two triangles, because I'm a visual person. So JKL, FGH, and I wrote them in the same order because I want my angles to be lined up. So we know that angle J is congruent to angle F. In order to be side, angle, side, I would need to know something about JK and FG corresponding and JL and FH. So if I look at my answer choices, I'm looking for the one that has a similar or a proportion that includes JK, JL, FG, and FH. So if I look, A does not, so A is out. B does. It's got the correct sides. And this one does not because of KL. And D does not because of GH. So these are including sides that we do not need that aren't correct. So my answer would be B. B is the correct answer there. All right. Now we're going to use some algebra. It says in number 3, we need to find the length of BE and the side length of AD. If you want to pause the video at any point and try any of these, and then you can unpause it, see if you're correct. All right, so I can set up a proportion and solve my proportion. So if I want to find X, X corresponds to the side of 3.5 in the other triangle. And then I can say side 3 corresponds with side 5 of the bigger triangle. So I did small triangle over big triangle, small triangle over big triangle. So all I did was line up my corresponding sides there. So when you cross multiply, you get 5x equals whatever 3 times 3.5 is, divide by 5, and you end up with an x value of 2.1. So BE is 2.1. All right, now I'm looking to find Y, because if I know what y is, then I can find out what AD equals. So I'm going to set up another proportion, and I need some more space. So I'm going to erase all this. So to find E, let me get rid of that. To find E, no, to find Y, there it is. So Y is the small triangle, and it corresponds with the side of the big triangle AD. Well, that is not 3Y, that is Y plus 3. Okay, so be careful there. We got little triangle side of Y corresponds to the big triangle side of Y plus 3. Equals, and now I can do the 3 and the 5. So small triangle over big triangle. So when I multiply this, I got 3y plus 9 equals 5y. I can subtract the 3y and I get 2y. And I divide by 2 and I get y to be 4.5. So because y is 4.5, I want to know what the side length of AD is. AD, remember, was y plus 3. So what's 4.5 plus 3? 7.5. So you just have to write a proportion based on corresponding side lengths. All right, number 4. You can try number 4, or you can just watch me do it. It'd be nice if you pause the video and try it. All right, I'm gonna get rid of all this stuff out of my way. Hopefully you've got it written down. If not, you can pause the video and go back. All right. Let's see here. We have to find QP and MP. In order for me to do that, I need to know what X is. So here's X. Oh boy, I can't put X. Not yet anyways. We don't have a proportion. We're going to learn about these special proportions tomorrow with parallel lines. So right now I can't use X because X is not a side of my triangle. So instead I can use 5 corresponds with 5 plus X, or X plus 5. Okay, let me do that again. You've got side 5 of the small triangle. Side 5 of the small triangle, and it corresponds with this whole side MP, which is X plus 5. Got it? All right, now I can say that that equals small triangle of 6 over the big side, which is whatever that is added together, which is 9 3/5. And you can change that to a mixed number, I mean an improper fraction if you prefer. So you'd put that and you'd get 6x plus 30 equals, I don't even know, I'm going to use my calculator here on my phone. And so I get 9.6 times 5 is 48. That was easy enough. Subtract the 30 and you get 18, divide by 6 and you get 3. So QP is 3, and MP is that whole side, so 5 plus 3 is 8. All right. Number 5, we need to find WR and RT. So we know that we have two similar triangles here. And so I can set up a proportion. I can say x plus 6 corresponds to 2x plus 6, and 8 corresponds to 10. Cross multiply, you get 10x plus 60 equals 16x plus 48. I'm going to subtract my 10 because I like to have a positive x value. So 6x plus 48 equals 60. Subtract my 48 and I get 12 equals 6x. So x equals 2. And because x equals 2, now I can find the length of WR by plugging in my x of 2. So I get 2 plus 6 is 8. And I can say 2 times 2 is 4 plus 6 is 10. So that's a nice isosceles triangle there. All right, number 6. Hallie's estimating the height of a Superman roller coaster in Mitchville, Maryland. She is 5 feet 3 inches tall, and her shadow is 3 feet. My doggy toenails, do you hear them? If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? So you probably did these in Math 1. And all you do is you draw two triangles. You got the height of an object with its shadow on the ground, the height of an object with the shadow on the ground. So I have two objects. I have Haley And I have the roller coaster. The roller coaster is 40 feet. Sorry, no, the shadow is 40 feet, so that goes on the ground. And we don't know how tall the roller coaster is. That's what we're looking for. Hallie is 5 feet 3 inches tall, and her shadow is 3 feet. So I need to convert this. What is 3 feet? I keep seeing 3 feet. The poor child is not 3 feet tall. She's 5 feet tall. All right, so 5 feet 3 inches is how much in a decimal? So I'm going to get rid of 5 feet 3 inches, and I'm going to turn this into 5 point what? Well, there's 12 inches in a foot, so 3 inches out of 12 is a quarter, so 0.25. All right, so now we're all in feet. So you have to make sure they're in the same measurements. You don't want inches and feet mixed up. So now I can set up a proportion. Height of the roller coaster corresponds to height of Hallie. Shadow of the roller coaster corresponds with the shadow of Hallie. Cross multiply and divide by 3, and you get the coaster to be approximately 70 feet tall. So if you put that in your handy dandy calculator, 40 times 5.25, divide that by 3. Oh, and it's exactly 70 feet. I didn't even round it. Look at that. All right, Adam's standing next to the Palmetto building in Columbia, South Carolina. And he's 6 feet tall, and his shadow is 9. So he's 6. His shadow, remember shadows go on the ground, 9. The length of a shadow of a building is 322.5 feet. How tall is the building? So there's my two similar triangles. You can set up a proportion. Height of the building to height of Adam equals the shadow of the building over the shadow of Adam. I always just start with my x. It does not matter where you start writing your proportionate. All right, cross multiply. So I'm going to say 322.5 times 6, and then divide that big old number by 9, and you get 215 feet. All right, so that is similar triangles and how you can use similar triangles to solve problems. If I went through something too fast, please know you can rewind the video and listen to me say it again to you. So try those 2 worksheets. Well, it's really 1 worksheet, it's front and back. Make sure you do those problems, screenshot it, send it to me, and then I'll respond with some answers there you can check your work with. All right, I hope you guys have a great day.